Hello everyone, welcome to Online Maths TV. Today we have a question on the board. It's an Olympiad challenge, and how do we solve for a pair of x, y that we satisfy this system of equations. If you're new here, this is Online Maths TV where we learn mathematics all the time. So if you've not subscribed, do well to subscribe. And when you subscribe, turn on the bell notification button so that you get notified whenever we drop an amazing video like the one you're about to watch right now. Now, the question is, solve square root of x plus the square root of y equal to 3 and the square root of x plus 5 plus the square root of y plus 3 equal to 5. So what are the possible pairs of xy that will satisfy this equation? All right, so without much waste of time, let's go into today's challenge. So from here, we take our solution. Now, we're going to call this equation 1 and this equation 2. So let's label this equation 1 and this equation 2. Now, from equation 1, I want to make s the subject of the formula by sending the square root of y to this side of the equation. So we're going to have this to be the square root of x is equal to 3 minus the square root of y. Easy. So the next thing we do here is to square both sides of the equation. Okay, so this will give us x. So our x will now be equal to 9 minus 6 root y plus y. But if you are confused there, then let's go systematically. Okay, let's go step by step. So this will give us here 3 minus the square root of y. So this is equal to 3 times 3 will give us 9. Then 3 times minus root y will give us minus 3 root y. Again, minus root y times 3 will give us minus 3 root y. And minus root y times minus root y will give us plus root y or squared. So from here, we have this to be 9 minus 6 root y plus our y, because this will go with this. Okay, so that's what I said before, that the expansion of this will give us 9 minus 6 root y plus y. Now from here, I want to move this y to this side of the board. Again, we have our x here, so we have our x is equal to this. So if we move this to this side, we give us here x minus y. This is equal to 9 minus 6 root y. So let's give this equation star. All right, so again, look at equation 2. I want to do same thing I did here to this equation. Okay, so move the whole of this entity to this side of the equation. So this will now give us here from our equation 2 now. So we have the square root of x plus our 5. This is equal to this side will give us here 5 minus the square root of y plus 3. Okay, so what do we do here now? Let's square this and square this side of the equation too. This will leave with this. So let's continue on this side. All right, so here we're now left with our x plus our 5 equal to, let's go systematically here again. So here we have here our 5 minus the square root of your y plus 3 plus bracket into 5 minus the square root of y plus 3. Also, so if we multiply out gradually, this time this will give us our 25. Then this into this will give us 5 into y plus 3. Then we go with this against this, so we have minus 5 into the square root of y plus 3 again. Then this times this will give us plus the bracket y plus 3 or to the square root or square. Okay, so from here, let's continue. Again, This will now give us 25. This will give us minus 10 root. This 10 root your y plus 3. Then the whole of this will go with this. So we're now left with plus y plus 3. Easy. All right. So what do we do next? Okay, let's rewrite this way. So what do we do next? Let's bring our entity here. So we have our x plus 5 here. I want to move this y to this side and take 5 to this side. So this will now give me x minus y equal to 25. This comes this way to give us minus 5 plus 3, then minus 10 into the square root of y plus 3. So this will end up giving us minus x minus y equal to, this will give us 23, then minus 10 into the square root of y plus 3. Okay? Now, let's give this equation star, star. Now, look at our equation star, which is this, and our equation star, star. There is a similarity here. We're having x minus y, we're having x minus y. So we can equate the two equations. So from here, we can also equate or equating equation star and star star. This will give us what? So this is going to give us here 2, 3 minus 10 root y plus 3 is equal to 9 minus 6 root y. You see that? Okay, so at this point now, because of this minus sign and this minus sign, I can interchange them. I want to move this to this side, move this to this side. At the same time, I move this 9 to this side. So this will give us 23 minus 9, this 9 please, plus 6 root y. This is equal to positive 10 root y plus 3. Okay, so 9 from 23 will give us 14. So we have 14 plus 6 root y equal to your 10 into the square root of y plus 3. If you watch carefully, 2 can divide through everything here. So 2 here will give us 7, 2 here 7, 2 here 3, 2 here we have 5. So we now have here 7 plus 3 into the square root of y equal to 5 into the square root of y plus 3. Easy. We are heading somewhere here. We want to eliminate this radical and also this radical. So what we do? Let's square both sides of the equation. So we square this. At the same time, let's square this too. All right. So if we square this, this will give us what? This will give us 49. Okay? Good. There plus 21 square root of y plus 21 square root of y plus 9 into y. Any confusion? Okay, then everything here equal to this times himself will give us 25. Then this will be exposed now, y plus 3. I believe there's no confusion here. Okay, so let's collect our items. So we have here 49. Okay, then we'll open up everything now. So this plus this will give us plus 42 root y, then plus 9y equal to, this will give us 25 y, yeah, 25y plus, it will give us 75. So let's collect our items, okay? So let's continue on this side of the board. All right, so from here, I want to carry all the terms on the right-hand side to the left-hand side. So if we do that, this will give us here 49, okay, which is our constant here, minus 75, okay, then plus our 42 root y. Okay, do we have any other root y? No. Then plus our 9y, then minus 25y, okay, equal to 0. So this from this will give us a minus 26, right? So we have minus 26, then plus 42 into the square root of y. Then, yeah, 9y minus 25y will give us minus 16. So minus 16y equal to 0. At this point, you discover that 2 is common again. So I want to divide through by minus 2. So if I divide through by minus 2, this will give us here 13, then plus 21, minus, here we turn to minus, please, because I'm divided through by minus 2. So minus 21 into our x there plus our 8 plus 8y equal to 0. So all I just need to do is to rearrange the system. So if I rearrange this, this will give us here 8y there minus 21 into root y there plus 13 equal to 0. Okay, the game is playing out now. Okay, so if you look at this now, we can form a quadratic equation from here by handling this radical here. So to handle this radical, we bring in another quantity or another alphabet to represent this. So let's bring out here p, okay? So you can say let p be equal to the square root of y. Therefore, p squared will now be equal to what? Y. So substituting into this expression here, this will give us, this now implies 8p squared minus 21p plus 13 is equal to 0. So because the coefficient of p squared is 8, so we multiply by this constant. So 8 times 13, that will give us 104. So 2 factors of 104 that we will multiply there will give us 104, and add there to give us minus 21 will be 8 and 13. So, and that will give us minus minus. So this will now give us 8p squared minus 8p minus 13p plus 13 equal to 0. So we can now group this, group this, group this, and group this. Again, we factor out 8p from here and 30 from here. So let's continue on this side again. All right, so from here, we factor out 8. We have here 8p. This, here we are left with p minus 1 into, there here we factor out 13. And here we are left with p, p, yeah, p, please, minus times plus will give us minus the 1. All right, everything equal to 0. So from here, if we succumb to the zero product rule, then we're going to have this to be p minus 1 into our 8p minus 13 equal to 0. So how p is equal to 1, or we have our 8p equal to 13. Divide through by 8, divide through by 8 here. So this leaves. So finally we have our p1, or p is equals to 1 or 13 all over 8. Okay, so we have our p1 and p2 in here. Now again, we recall there's a place where we say let p be equal to the square root of y, right? Okay, so from there we now establish that p squared is equals to y. So let's go and look for the value of y, because the question is to look for the value of x and y. So from here we now say recall that we said let our p squared is equal to y. So we're taking case 1. So for our case 1, what is our p? We have p is equals to 1. So yeah, this will now give us our y is equal to 1 square. And 1 square will give us what? 1. So therefore, our y1 is equals to what? 1. So let's give this as our y1. We'll solve for our y1. Now let's look for our y2. So for case 2, what is our p? P2 is equal to 13 all over 8. Okay, so let's continue on this side again. All right, so our y2 is equal to our p squared 2, which is equal to, we have 3 all over 8 all square. So we have y2 is equal to 169 all over 64. So this is our y2. So we'll solve for our y2. Here we have our y1. So let's go ahead and solve for our x1 and x2 that will correspond to y1 and y2. Now recall, when we made as the subject of the formula, we have something like this. So recall that we have our x is equal to 9 minus 6 into the square root of y plus y. You remember this? All right. So from this expression, we can look for our x1 and x2. So from here, we now have our x1 is equal to 9 minus 6 into the square root. What is our y1? Our y1 is 1. So we have here 1 plus 1. So this will give us 9 minus 6 plus 1. And if we simplify, this is 5 minus this will give us 4. So this is our x1. Okay. So we've gotten our x1. Now let's look for our x2. So our x2, from here again, from this expression, this will give us 9, then minus 6 into the square root of, what is our y2? Our y2 is 169. So we have 169 all over 64. All over 64, okay? The square root is covering everything. All over 64. Then plus, again, 169 all over 64. Okay. So with this, let's go ahead. This will now give us our x2. This is equal to 9. Okay, minus 6. The square root of this will give us 13 all over 8, close bracket, plus 169 all over 64. So 2 here will give us 4, 2 here will give us 3. Okay, so I use this to multiply this. So let's continue on this side of the board to get our final answer for our x and y. Okay, all right, so from there we have our x2 will now give us here 9, then minus 3 times 30 will give us 39 all over 4 plus 169 all over 64. Okay, of course we know the LCM here will be 64, right? So if we simplify this, we give us here 64. 9 times 64, that will give us, because this is all of a divisible one. So 1 here will give us 64. 64 times 9, that will give us 576. So we have 576, then minus here. So we have 4 into 64 will give us a 16, right? So 16 times 39, that will give us 624. So we have 624. Okay, then this divide this will give us 1, and the 1 times this will give us plus 169. All right, so if we carry out our simplification here, 576 minus 624 will give us minus 4. Okay, that will give us minus 48 there. Minus 48 plus 169 will give us a 121. So we have here 121 all over 64. All right, so this will now give us our x2 is equals to this. So therefore, our x comma y is equal to, let's rule this out first. Our x comma y. What is our x1? Our x1 is 4. So we have here 4, comma, and our y1 is 1. Okay? Then again, our x2 is what we solve for. Yes, please. 121 all over 64. Okay, comma, and our y2 is 169. So we have 169 all over 64. Okay, all over 64. So these are the pair of answers that will satisfy this our Olympiad maths. Okay, so our x1, y1, x2, y2 gives us this. Okay, so this marks the end to this rhetorical challenge from Math Olympiad International. Okay, remember, this is Online Maths TV, so if you've not subscribed, do it to subscribe. Again, in the process of solving, if you notice any error, do not hesitate to drop it in the comment section. Again, if you learn something from this challenge, drop it in the comment section. It can be, thanks Jakes, well done for a job well done. Okay, so thanks for always be there. Remember, Jakes loves you, and every one of us at Online Maths TV loves you. Bye for now.